Our project is the Sensor Mesh Network. I'm Jonah Temple. This is Oliver Trin, Daniel Ogerchuk, and Neelan Vakil. Okay, so the problem our project is solving is it's based on the Internet of Things. So the Internet of Things is great, but if you're outside of the network range, then your things don't work. And so our project is effectively extending that range with a Bluetooth mesh network.
So the way we implemented the design for our project is we have several independent network nodes which calculate their own cost. And this cost they advertise to all the other sensors in the pool, for example. And they will send their data that they're periodically logging over Bluetooth to the cheapest node along their path to Wi-Fi. And finally, when it reaches a Wi-Fi node, it will send it off to the cloud to be processed wherever is relevant.
The hardest challenge we had to face was probably creating our own protocols for the mesh network. We didn't use any previous protocols and we made it all from scratch, so it took a little bit.
So we learned various aspects of product development, like working in a team, splitting up different tasks. The first semester, we kind of split up all of our tasks, had Jonah working on Eagle, Daniel and Oliver doing Bluetooth, I was working with sensors. And then at the end of last semester, we kind of started merging all of those, and we started to get some issues combining different aspects, which we were able to work through and get working for this demo, as well as improve last semester's initial prototype. So we learned how working separate and then bringing it all together can cause issues, but then we were able to mitigate those issues and figure out the best solution for our problem. Okay. So what our product actually does is once the user buys it from the store or gets it, they'll open it up, press a button. That button will put it into a configuration mode, which then the user will be able to connect to the device directly, load a web page, input their Wi-Fi credentials, and then that node will know, okay, this is the network that I want to connect to. This is the network I should be looking for. Then we have periodic deep sleeps in order to conserve battery and aim for that 1 month battery life. So once they wake up from a deep sleep, they send and receive broadcast transmissions, which tell them which nodes are around them and if any of them has a way out of the network. And then they'll get their sensor data and then send it off to either, if they don't have Wi-Fi, they'll send it off to the node that has the lowest cost, or if they do have Wi-Fi, they'll send it directly to Wi-Fi, and then they'll determine, okay, is it time for me to go back to sleep to conserve battery life? If it is, they'll go back to sleep. If not, then they'll continue the loop of sending out broadcasts, sending out sensor data, and then continuing through that loop.
All right, so here we have an example network setup, using an example of maybe a pool in a water park, where these two buildings here have access to Wi-Fi, but it only extends off to about here. And the customer has placed various sensors throughout their pool and hot tub, and they're automatically discovering each other, collecting sensor data. Right now, you can see they just went into a deep sleep, and they'll all wake up together. They'll discover nodes next to each other, and we'll start seeing this EL wire light up. The blue represents a Bluetooth transmission happening between nodes, whereas a green represents a Wi-Fi transmission off to the cloud. So shortly we should see these two sensors connect to Wi-Fi and start transmitting. So now node 6 is transmitting to the cloud, and we'll see the other nodes start sending data through these two. We can modify the topology to make it dynamically react. So if we, for example, turn off node 4, the next time they all go to sleep and wake up, they'll use an alternative path to Wi-Fi. See, 3, since it doesn't have access to 4, has to go through 2 to 5 to 6 to get data out. And that's our demo.